Hey there, statistics class. Hopefully I'm not shouting at you right now because I'm trying to talk in a nice calm voice, and sometimes it's just too quiet to hear. In this lecture, section 2.2, we're going to talk about different kinds of data displays, specifically bar graphs, circle graphs, Pareto charts, and time series, and why this is useful. Again, the idea is we're going to do these things by hand first, so you understand the mechanics of it, why you need to be consistent in how you do it, and then I'll show you how to do it in spreadsheets. So we've been working with histograms, and those are great, but histograms, again, are buckets of data, so that you need to have quantitative results. In this section, we're going to talk about things that are often qualitative or in categories, like the number of people that drive Chevy, the number of people that drive Ford, Toyota, etc. We can quantify those numbers, but really, those are qualitative categories. So we're going to start with bar graphs, and again, you all know what bar graphs are, but just to review a couple features and think about it a little bit deeper. Of course, they can be vertical or horizontal. The bars have to be of the same width and spaced equally apart, and this will make more sense. The length of the bars represent the variable being displayed, or the frequency, or the percentage, right? And the same measurement scale is used for the length of each bar, so you don't have bars representing different lengths. And of course, the last thing, which we often forget, is you need to title the axes, the labels, the scale, so that way whoever's looking at your graph knows what to make of it. So in this example here, let me get my picture out of the way. You've got two bar graphs, and they're looking at life expectancy for men and women. And both graphs are showing the same information, but clearly the graph on the right does a much better job at showing the difference between men and women. And again, when I look at my key up here, blue is men and purple is women. You'll notice that the spacing is very even. The scale, vertical scale, is accurate. But you'll notice here that it starts at 0 and increases by 20. And on this one, it also starts at 0, but you see this little symbol here, and it's called a break. We're going to talk about this in a moment. You have to remember your graph is always going to start at this point 0, 0. Think of it that way. Now with this break, then we jump up and we say, well, now we're going to start at 65. Each one of these units is a 5-year increment. I realize I'm just off the page. That's all right. You don't need to see me, whatever. But this is a much more telling picture because everything is also to scale, but you can more easily see the difference in life expectancy between men and women. So what's the point here? These are called cluster bar graphs because there's 2 bars for each year of birth, right? And yeah, I think I've already talked about that. So let's talk about this break a little bit more. So that break is called changing scale. And again, the important thing is you are always starting at the origin, but then you can put this break symbol or a squiggle, and that way you can tell your audience, all this other information leading up to it is irrelevant because it's the same. But in this specific range, that's where you really have to pay attention. So you're going to look for that when you do some of these in your assignments. So the next one is a Pareto chart. Aha, there we go. A Pareto chart. And again, this is a bar graph, but the bar heights are represented as a frequency. So for example, here there were 52 traffic accidents. What are we looking at? The reason people were late. Traffic was late. I had to get my kids to daycare, public transportation, whatever your reason was. So this is a frequency. And you'll see that the frequencies are in descending order from the most frequent to the least frequent. Now they did something else really cool on this Pareto chart. They also included an ogive. And again, this is the mistake I made the other day in class, but when we connect the dots on our ogive, accumulating to 100%, we just make them straight lines, and that way you can then see what has the steepest slope in what of the classes. Again, anytime, just pause the video if you need more time to look over this stuff. Now, on to an example. Another very popular one is a circle graph or a pie chart. It's pretty safe from misinterpretation because we all get the idea of, well, a whole pie. Let's just review one thing. A whole pie is 360 degrees. So this data, let's make one right now. This data was from the class survey started at the beginning of the year when I talked about how many people are in each grade. And we've got 3 sophomores, 5 juniors, and 6 seniors. So if I wanted to calculate the frequency, well, that's 3, 5, and 6. And if I want to calculate that percentage, really what I'm talking about is this is 3 of 14. Juniors they're 5 of 14, and seniors there are 6 of 14. So when you look at those percentages, that means sophomores are 21%, juniors are 36, and seniors are 43. Great, I mean that's all good, and that adds up to 100%, but then how do I actually make the circle graph or the pie chart from that? Well, what you need to do is multiply 0.21 or 21% times 360, and you'll figure out how many degrees it is between what you're trying to draw. So for example, we know 180 degrees is the diameter of a circle. So let me just start like this. Let me just put a little line here. And again, I should be using segments, not that. Now, this first group is 77. That's 90. So I'm going to call that 77. My next group here is 129. And if you recall, it's 360 divided by 3 is 100. Sorry, 360 divided by 3 is 120. So 120 degrees is a third of a circle. So that means this is about a third of a circle. So I'm just a little bit more than a third. And let me label this right now so we're all on the same page here. Let me use my highlighter. So I'm going to use, this is yellow. This is going to be green. I should have just done that right there. I don't know if I can paint that in. And then let's add, oh, Kaylee, what do you want? You want purple? Okay, we'll do purple. Nice. And so that ends up being 154. And then I can label these properly as well. I can say, hey, these are, I'm freehanding here. Bear with me. I know. You're being really patient. Then you want the calligraphy pen? Okay, I'll do the calligraphy pen. So this green is going to be 11th graders. That says 11th. This one over here, the yellow, is 10th graders. And I just heard Stephen say, Mr. Rising, that pen ink is just way too thick. Well, let's just make it a little thinner. And then, of course, this is going to be my 12th graders down here. And that's just absolutely disgusting and horrible, but it's the best I can do with a mouse. Okay, that's actually really important. This step is, everybody seems to figure out the percentages, but then converting it to degrees and how that works out on a circle is sometimes that hang up. I digress. I move on. Now, the last one we need to talk about is time series. And the key on time series is the horizontal scale is time, and that the variable being measured is the vertical. You always want to make sure that the interval on the bottom is at regular intervals. So if you're talking about years, hours, seconds, millions of years, whatever, each bar has to be the same width apart so you can actually look at the data. And of course, these are really popular. Oh, let me go back. These are really popular in stock prices, historical things over time. I thought I had a picture here. Let me see if I do. I don't. I think you've all seen a time series before, so I'm not going to stress it out. Let me, I can plot one out here. I think you guys all know what a time series is. Tell you what, if you don't, look in your book. All right, so time series might start someplace. Of course, you've got your labels. Usually it goes like this, right? And of course, all of these are equally spaced apart: hours, minutes, seconds, years, etc. The last slide I'm going to leave up, and again, you might want to pause this. I'll get my mug out of the way. There we go. I'm out of the way. How to decide which type of graph to use is very important. And again, bar graphs, Pareto charts, circle graphs, time series. And then last but not least, probably the most important thing is for any graph, and I'm going to take a moment to read this, provide the title, label the axes, what are you talking about, identify the units. You're measuring degrees what? Degrees in Fahrenheit, Kelvin, Celsius, okay? Don't let artwork or a skewed perspective cloud the clarity of the information you're trying to display. Just do it and let the data speak for itself. All right, I kept it to 10 minutes. I hope that was helpful, and let me know if you have any questions.